Good day, ladies and gents, and welcome to StomanMaths. Today's lesson is going to be a very important lesson because today we are going to start with algebra. Now, algebra is very important. You are going to use algebra from here on end, right up to the end of your schooling career. And if you continue in the sciences or in engineering or computer science or any other subject like that, you need to understand, you need to know algebra, and you need to know it well. All right. So today you must pay particular attention to this lesson and make sure that you understand it completely. Alright, now let me just say right off the bat, if there's anything in this lesson today that you do not understand, please leave a comment down below, alright, and I'll have a look at it and I'll do my utmost best to explain algebra to you, alright, to make sure that you understand it completely. Alright, so without any further ado, let's just jump right into it. Okay, so I'm going to start you off with something that you may already be familiar with, alright? Maybe you've done something like this in your earlier schooling years, and it looks like this. We've got some kind of mathematical, let's call it a calculation, alright? And it's simple, it's just plus 2, alright? So this block with the plus 2 in it denotes some kind of mathematical calculation that we want to do, and how it works is we feed a number into it. Let's say, for instance, we feed the number 2 into it, all right, and then inside this little block here we do our mathematical calculation, and what we get out then is of course 4. All right, so what happens inside here is we've got 2 plus 2, and of course that gives us 4. All right, and so we can add other numbers to it as well. We can add, let's say, a 5, or we can add, we can choose anything. Let's say we choose a 9. So if we add 5 into this mathematical calculation block, if we add a 5, then obviously we will get out 7, because 5 plus 2 is 7. Alright, and if we add 9, then we'll get out 11, because 9 plus 2 is 11. Okay, very, very easy. I'm sure all of you can understand this. Stick with me. So now we are going to add an extra step. Alright, we'll spice it up just a little bit. We'll still have our plus 2 calculation block, okay? But we are going to add another block to that, and inside this calculation block, we'll say we multiply with 3, and then we will go on to plus 2. And so now we do the same thing. We add a number into it, and let's add the same numbers into this calculation sequence than we had in the first one. 2, 5, and 9. So we'll add 2, we'll add 5, and we'll add 9. And now let's have a look at what happens. If we add a 2 into our sequence, we have 2 times 3, and that is 6. And now we take our 6 and we add it into the plus 2 block, and then what we get out is going to be 6 plus 2, and that of course will be 8. Alright, so this mathematical, let's call it a mathematical machine if you want to. This little mathematical machine has got 2 blocks inside, and these 2 blocks inside do some kind of a calculation, and when we feed it with the number 2, it gives us the number 8 out on the other side. Alright, so we'll say this is the input and this side is the output. So if I put 2 into my maths machine, the output will be 8. Okay, so let's go and see what happens if we put 5 into the machine. If we put 5 into, then the first step will be 5 times 3, and that's going to be 15. And then we take our 15 and we put it into the second step, and then we have 15 plus 2, and that'll give us an output of 17. Okay, so for the input of 5 into our maths machine, okay, for an input of 5, the output will be 17. Okay, and let's do the same with the 9. 9 times 3 is equal to 27, okay? And if we take 27 and we put it through the second step, we have 27 plus 2, and that gives us 29. Okay, again, very easy. The concept is very straightforward. We take a number, we put it into our maths machine, something happens to it, and it gives us an output. Okay. Now, in mathematics, there's a word that we use for these two blocks. All right. There's a word that we use to describe our maths machine. All right, the calculations that happen inside this machine. And that word is function. Function. Okay. So whatever is happening inside this big block here, all right, whatever the calculations might be that we have inside that block, that entire block, all of those calculations together, we call that a function. All right, and the function has got a number of characteristics. The first characteristic is that for every one input that goes into my function, all right, there will be only one output. And here you can see that when we add, or when we put 2 into the maths machine, into the function, all right, we get one output, and that output is 8. Okay, so think of it like this. Something, a calculation, all right, or a number of calculations, a number of steps, something is taking the input of 2 and it does something with it. It does some work on it, some maths work on it, right? It's performing some kind of a function, and that gives us an output. It delivers to us an output. Okay, now the important thing is, for every one input, there will only be one output. In this first case, the first one we had a look at, that's also a function, and that function only contained one calculation. All right. The second one here, this function contained 2 calculations. Okay, so the first thing that's important for us, the first thing that we have to notice today is the concept of a function. All right, and we are going to use this word, a mathematical function. We are going to use it a lot. Okay, from here on up until the end of your schooling career, and even onwards, we are going to use a function a lot. All right, so you need to learn the definition of a function. And like I said, a function is a mathematical sequence, a sequence of calculations that transforms an input into an output. And the important thing is, for every one input, there can only be one output. So that's very important to remember. All right, so let's move on. Let's try another one. Let's keep our times 3 calculation. We'll keep that one. And we'll also keep our plus 2 calculation, all right, our plus 2 block, but we add an extra step. And this extra step looks like this. Whatever we feed into this first step, we take that and we raise it to the power of 2. All right, we square it. And that result is then fed into the second step, into the times 3 step, and then from there on into the plus 2 step. All right, so again, let's go and have a look at this. This entire thing, the 3 steps now, that thing is my function. We refer to that as my function. Okay, now let's go and add some numbers into it. Again, let's use 2, 5, and 9. Let's add those numbers into my function, into my maths machine. All right, so when we add 2 into my function, the first thing that happens is we have to square it. So 2 comes here, and we now have to square it. So we have 2 squared, and that gives us 4. 4 now goes into my second calculation, my second step. And here we have 4 times 3, and that's 12. And then we feed the 12 into the final step, all right, the plus 2. And 12 plus 2 then becomes 14. So the output, okay, the output of this function, when we feed 2 into it, the output becomes 14. Can you see? Still relatively easy peasy to do, okay, right? You can pause the video here and quickly calculate the outputs for 5 and 9, all right? And then when you are done with that, you can play again and then see if you get the same answers as me. So let's go and have a quick look at it. If we feed 5 into my function, the first step will be 5 squared, and that's going to be 25. Then we take 25, we multiply it by 3, so we have 25 by 3, and that's going to be 75. And then finally, we take it into the final step, and we add 2, and 75 plus 2 will be 77. So the output, when we feed 5 into my function, the output will be 77. And again, there's only one output. Right, for each input, there's only one output. And we'll do the same with 9. We have 9 squared, that's going to be 81. And then we have 81 times 3, and that's going to be 243. And then we feed that into the last step, and that's going to be 243 plus 2, and that gives me 245. So for the input of 9, the output will be 245. Easy peasy. All right, so like I said, this stuff you probably already had some exposure to this, some exposure to these little spider diagrams, I like to call them, because you know it looks like a little spider with its body and its legs. Okay, so you might have already had some exposure to this, and the new thing today is to learn that this calculation, these calculations, we refer to them as a mathematical function. Okay, so we take an input, we do some work with it, all right, we change it a little bit, we transform it, and it gives us then an output. And for every one input, there will be one output. All right, now let's move on. Let's get to the real algebra stuff. Let's begin with our second example. Let's have multiplied by 3 again as the first calculation, and then we'll have plus 2 again as the second calculation. All right, so this will be my mathematical function. This block here, this is going to be my function. Now, just a second ago, we fed numbers into the function. We fed a 2 into, and it gave us an output of 8. Okay, can you remember? All right, if you forgot, just rewind quickly, go and have a look at it again, all right? And then you'll see when we add 2 into this function, it gives us an output of 8. Now, here's the important thing, very important. Sometimes it might happen that we know the function. We know what the calculation is that we are supposed to do, but we don't know what we must feed into it. This is unknown to us. All right, we don't have a number that we can feed into the function, but we know what the function is. And so let me give you an example. Let's say, for instance, you are writing your exams. All right, and you've got many subjects. And for each of those subjects, you get a final mark, all right? And then in your mind, you know how to calculate the average, all right? That will tell you that you either failed or passed the year or the semester, whatever. Okay, so you've written your final test, and that test is still in the process of being marked, so you don't have the final test mark yet, all right? But you know how to calculate it, you just don't have it yet. And so now you can guess, all right? So usually what we all do is we calculate what is the number, the least amount that I need just to be able to pass. And so you do those calculations and you think to yourself, okay, if I get 50% for the test, at least then my average will be high enough and I'll be able to pass the year or the semester or the course or whatever it is, okay? But we don't know yet because the test is not released, the mark has not been released yet, but you know how to calculate it. So then you think, okay, if I score 75% on it, I might even just pass with a distinction, and that's going to be much better for me, okay? But I don't know the number yet. I don't know the number yet, but I know how to calculate it. So I know the function, all right? I know the calculations. I know these blocks, what they should be and what they should look like. But I don't know what to feed into them yet. because I don't have the mark yet. All right. So now what do we do in this case? And a couple of very clever mathematicians came together and they said, okay, this is what we'll do. We'll use a placeholder. We'll use a placeholder. And the placeholder will use letters of the alphabet instead of numbers. We'll use letters of the alphabet to indicate placeholders for us. And what we can then do is we can do the calculation so long, all right? So we can do the function and get some kind of an output, and then we wait for the number to eventually be revealed, and then we just slot that number into that calculation, and there we go, we have the answer. But if we put a placeholder in it, it means we can at least carry on with our calculations. We don't have to stop and wait until we get the number. All right, we can carry on with our calculations and we can continue doing our work. And then later on, when the number becomes known, then we can add it into our function. All right, and that's going to give us the answers that we require. So we use a placeholder. And this is very, very important. You must remember this, please, a placeholder. Now, the most common letter that we use to indicate a placeholder is the letter X. And notice how that X is written. It's not written like this with straight lines. This symbol here, this is the symbol for multiplication. All right. So in mathematics, when we want to write an X, we use this curly shape. All right, we use two curly shapes to denote the letter X. Okay, and so now this placeholder, the letter X, that we want to feed into our function, this placeholder may take on any number. All right, so the placeholder can be any number. It can be 1, it can be 0, it can be -2, -12, 12, 12 million, 527, it doesn't matter. The placeholder that we use, the X, the letter, can take on any number, any numerical value. And so now let's go back to our example where you've written the test and you are waiting for your test results. All right, the X in this case can represent 50% or the 75%, or maybe you did really well and it represents 92 or 96, or maybe you aced it and it can also be 100%. Okay, so the important thing is that the placeholder can take on any number. We just don't know it yet. All right, we don't know it yet, and that's why we use the placeholder. Okay, so now we want to continue doing our calculations despite the fact that we don't know the number yet. So what we do is we use our placeholder and we now feed that into the function. So now we've got X and we are going to feed X into our function. And the first step, the first thing that we need to do is we have to multiply the X by 3. So we'll have X multiplied by 3. Okay, so now this is important, and think of it like this. If we have one placeholder, 1x, and we multiply that one placeholder by 3, then how many placeholders do I have? How many x's? All right, then we have 3 x's. Can you see? We have one placeholder, we have one value, not a value, one unknown, all right? And I multiplied by 3, so now I have 3 placeholders, 3 unknowns. Okay, you can also think of it like this. If I have one apple and I multiplied by 3, then how many apples do I have? I have 3 apples. So x times 3 is then 3x. Okay, now in mathematics, when we have a numerical value multiplied with an unknown multiplied with a placeholder, the convention is to put down the number first, followed by the letter. So if you see 3x, it means 3 times x. Okay, and you know, it's not wrong if you write x3, but it just looks weird. All right, because all of us, we are all used to having the number first and then the letter. All right, So that's important to note as well. So x times 3, 1x, and I have 3 of them, alright, I multiply by 3, so I have 3 of them, and that becomes 3x. And now I take my 3x and I put it into the second calculation, the second block, and all that does is it adds 2. So I come out with, my output will be 3x plus 2. 3x plus 2. Alright. So again, I'll say it again. It's important to understand this. There might be times when we know the function, we know how to do the calculation, we just don't know what to put into it. This is unknown to us. Okay. And now to keep on going with our calculations, alright, not to have to wait with everything to stop and to have to wait for an answer to eventually come to us, alright, what we do is we choose a placeholder. And the placeholder, those are letters of the alphabet instead of numbers. And like I said, the most common one that we use is the letter X. Then we can feed X into our function and we can continue with the calculation. Right, in this case, if we feed X into this specific function, the output will be 3x plus 2. Okay, are you with me? Please, if you don't understand, ask in the comments and I'll explain it to you again and again and again until you understand it. Alright, you can also rewind this video and then just have a look at it again. Listen very intently, alright? Pay attention and I'm sure you'll snap it in no time. So let's move on. Let's increase the difficulty only slightly. And let's have the following. Can you also remember that just a little while ago we had a look at an additional function, alright? And it looked like this. We feed something in and whatever we feed, we square it. We take it to the power of 2. Then whatever comes out, we multiply that by 3. And then whatever comes out of that, we add 2 to it. Okay, can you remember that one? Again, this whole thing, all three of these calculations, all of them together, that represents my mathematical function. That's my function. And now we want to add to it inputs, and it's going to give us outputs. Okay, so now again, let's for now assume we don't know what the input must be. We don't know what it must be, but we know the calculation. I mean, here it is. This whole thing here, that's my function, that's my calculation. Okay, so what do? Can you tell me, can you remember? That's right, we use a placeholder. We use a placeholder to be able to continue with our calculation, and we are going to use the letter X. X is the most common placeholder. So we feed X into our function. And now let's go and have a look at what's going to happen with that X as it moves through this function block. Alright, so here it goes. Into, and the first calculation in my function is we have to take the X and we have to square it. Alright, so when we square something, so let's say for instance 2 to the power of 2, 2 squared, that is the same as 2 times 2. Alright, do you agree? Alright, that's the same as 2 times 2, and that's equal to 4. Or you can take 3, 3 squared is the same as 3 times 3, and that's going to be 9. Okay, so when we square the X, what do we have? We have X times X. X times X. Okay, you might remember your exponent laws from grade 9, alright? You may or may not be familiar with that, but basically what it comes down to is if you have the same base that you multiply, if you have the same base that you multiply, alright, you can simply add the exponents, you can add the powers. Let me explain. If I have 2 to the power of 2 multiplied by 2 to the power of 3, I notice that it's a multiplication calculation, alright, and I have the same base. That means that I can add the two powers together, so it becomes 2 to the power of 2 plus 3, which in the end is the same as 2 to the power of 5. Okay, Now, why can we do it here? Why are we allowed to do it there? Because, ladies and gents, this placeholder, which is an x, all right, it's denoted by the letter x, and this placeholder is the same placeholder. And it must be the same because we are squaring them like this. It means 2 to the power of 2 means 2 times the same 2. 2 times the same 2. And so if I square the x, what I do is I take that placeholder and I multiply it with the same placeholder. So I've got a multiplication sum. I can see that, all right, a multiplication calculation. And I am multiplying the same bases with each other. So I'm allowed to add the exponent. I'm allowed to add the powers. So that then becomes x to the power of 1 plus 1. Because remember, if a number does not have an exponent, if it does not have a power, it's the same as being to the power of 1. All right, it's the same as being to the power of 1. Okay, so we have x to the power of 1 multiplied by x to the power of 1, and that's going to give me x to the power of 1 plus 1, which in the end is the same as x squared, or x to the power of 2. Okay, now we take our x squared and we put it into the plus or the multiply by 3 block. The multiply by 3 block. Okay, now have a look at what happens now. We have, in this block, we have x to the power of 2 multiplied by 3. So now the way we think about this is we have 1, I've got 1 x to the power of 2, all right, and I multiplied by 3, then I must have 3x to the power of 2's. All right, does it make sense? If I've got 1 pineapple and I multiplied by 3, then I've got 3 pineapples. So this whole thing, you can think about this as a pineapple, all right, as one thing. So I've got 1x to the square and I multiplied by 3, so I have 3x to the squared. So I have this 3x to the square, x to the power of 2, sorry. And again, notice we write the number first and then we write the letter. So 3x squared. All right, that's what happens when you multiply the x squared with a 3. And so now we take 3x squared and we put it into this block here, and our result, or our output, so when we feed x into it, the output becomes 3x squared, and we add 2 to that. Okay, does it make sense to you? All right, I hope it does. It should be a little bit clearer now. Okay, so now let's move on. Remember now we had this. We had the function, and the first block was we squared whatever came into it. Then we multiplied by 3, and then we added 2. That's what we had. All right. And this whole thing here, again, this is my function. This is my function. And we said if we add x into my function, the output will be 3x squared plus 2. If we don't know what the input is going to be, if that is unknown to us, and we use a placeholder, all right, to indicate this unknown, and remember again, the placeholder can assume any numerical value, all right? If we don't know what the input is going to be, then it makes sense to us that we don't know what the output is going to be. Do you understand? I don't know what the input is. I know what the calculation is that I have to perform. And so if I don't know what the input is going to be, then also I don't know what the output must be. So if I don't know what the input is and I use a placeholder for it, and if I don't know what the output is going to be, then I might just as well use another placeholder, okay, to denote the output. Does it make sense? All right, I don't know what the input is going to be, and so I use a letter, I use the letter x, and I don't know what the output is going to be, so I may also use another letter to denote the output. And that's exactly what we do. And the most common letter that we use to give us an output is the letter Y. Alright, it's the letter Y. Now, please remember, you can choose any letter of the alphabet. Really, it doesn't matter. The important thing is that we are using letters to show the places, or to take the places rather, of numerical values that we don't know yet. Okay, so we can use a Y as the output because we don't know what the output must be. So now we have this. If I put X into my function and it gives me 3x to the power of 2 plus 2, and I say that this output is the same as the letter Y, the placeholder Y, then I may say that Y, the output, the unknown that I don't know, is also the 3x squared plus 2. Alright, these two things are the same. Right? I just said I don't know what the output is going to be, so I use a placeholder, the letter Y, for it. And if I put x into the function, it gives me 3x squared plus 2, so the Y and the 3x plus 2 must be equal to each other. Alright, they must be the same thing. Okay, and now ladies and gents, we have here a mathematical function in, well, let's say in a maths format. It's no longer little blocks with calculations in them. Alright, we are done drawing pictures now. We are finished with that. So it's no longer a picture. Alright, it is now in a numerical, or in, let's call it a mathematical version, in a mathematical notation. Okay. And so what we have here, this is my function. This is my function. And why do I say that this is my function? Well, let's go and have a look at this now. Remember, in the beginning, we fed a 2 into this function. And can you remember what the output was? Alright, if you remember correctly, that output was 14. Okay? It was 2 squared, which was 4, times 3, which is 12, plus 2 gives me 14. Alright. So now, let's take this function here. And let's for now assume that all of a sudden it becomes known to us that the unknown x that we wanted to feed into the function, that unknown x has got a value of 2. Alright, so all of a sudden it becomes clear to us. We realize that value, or we find out that value of x must be 2. Okay, so now what do we do? Well, we use a process called substitution. Substitution. And what that means is we take this known value of x now and we go and put it into the places, all right, into the spots where we had unknown placeholders in our function. All right. So what we are doing is we are substituting the unknowns with known values. Okay, so let's see what happens now. We've got the output, which is still unknown to us now. And we know now that the x must be a 2. So we've got 3, and we multiply that with 2 to the power of 2. We multiply that now with 2 to the power of 2 because we have substituted the x with the known value of 2. So it now becomes 2 to the power of 2, and to that we add another 2. And what does this become now? We now have 3, and 2 squared is 4 plus 2, and that gives me 12 plus 2, and that is 14. The same 14 we had here. Can you see? Can you see? All right. So this function we obtained by passing x through our function drawing, all right, our maths machine. Okay, this function is now in, let's call it a maths notation for now. Okay, it's got a different name, we'll get to that just now, but we'll call it our maths notation. It's no longer a drawing, it is now numbers and unknown letters. All right, variables we call those. All right, placeholders for now. Okay, so this function here that we obtained by passing x through this maths machine This is the same. This function here and this function here, these are the same functions. Okay, so now we are not going to draw pictures from here on forwards. We are going to use this way to denote, to indicate mathematical functions. Okay, so again, I say, again, all of a sudden, we realize x must have a value of 2, and if it's got a value of 2, we can substitute that value of 2 into all of the places where we have an x, okay? And then we can use this function to calculate the output. So the output, y, is now also known to us because the input became known to us. It had a value of 2. Do you understand? All right, does it make sense to you? Let's say the x takes on a different value. All right, let's for instance say that x was not 2, x was 5. Okay, now can you remember when we had a 5 going into my machine, the output was, can you remember, the output was 77. So we used the same procedure. We use substitution again, but we are going to use this form of the function. So now we say we have y, and y is equal to 3 times 5 squared now, plus 2. That'll then be 3 times 25 plus 2, and that's going to be 75 plus 2, and that's going to be 77, just as we had when we were drawing pictures. Okay, so again, the point I want to make is that the pictures and this form of the function, it's the same thing. Right, now, the next important thing that you must learn and know in algebra is what we call function notation. And it works like this. We call this part of this equation, we call that part a function of x. And we write it down like this. We say that we have a function f of x. Now please, this is important. This does not mean f times x. It does not mean f times x. Alright. If you wanted to write f times x, if you wanted to have two different placeholders, one being an f and one being an x, alright, you would know in your expression or in your equation, you would know that you've got f times x. And sometimes you can put a dot in between if you want someone to really understand that it means f times x. But as far as we can, we refrain from using f and x together because we use f to indicate a function of x. Alright, and that's exactly what we say. Now, what do we mean by that? When we say we have a function, it means that we have some calculations. Alright, some calculations. 3 steps here. Alright, we've got some calculations, and inside those calculations we have an x. And it may be x to the power of something, or it may simply be an x, or it may be a negative x. It doesn't matter. There may be more than one x, there may be only one x, it doesn't matter. Inside those calculations there's an x. And we say that's a function of x. So if we take this whole block here again, which was our mathematical function, we say that our function of x is 3x squared plus 2. And so now let's have a look at this. We've got some calculations there and there, alright? We've got a 3 times x squared plus a 2, some calculations, and inside those calculations is an x. And there is that x. Alright, inside those calculations we have the x, and it's situated right there. It doesn't matter where it is, the important thing is there must be an x inside. Okay, so now you might say, but what happened to this one? What happened to the y? Now, how did we all of a sudden go from y to fx, or to f of x, or to a function of x? Alright, don't stress about it, it's the same thing. You can say that y is the same as the function of x. The reason we use the y is because the output was unknown to us when we had an unknown input. All right, but you might just as well go ahead and use function notation as well. All right, so if we say a function of x, then we are using function notation. Now let's go back to the cases where the x became known to us. So if it becomes known to you that x is 2, then the function of x will become the function of 2. All right, and so what does that mean? The function of x becomes the function of 2. So basically that means that wherever we had an x, we replace it with a 2. So we substitute all the x's with a 2. So the function of 2 will become 3 times 2 squared plus 2, and we know by now that's 14. Okay, can you see? So we had a function of x, which is a number of calculations with an x somewhere inside. In this case it was 3x squared plus 2. And if we know that the value of x is 2, then we say that the function of x becomes the function of 2, or you can say the function where x equals 2, and wherever we've got an x, we replace it with a 2. Alright, and if we had a 5, if it was this case, where x was equal to 5, we say the function where x is equal to 5 will be 3 times 5 squared plus 2, and that's going to be 77, the same as this calculation that we did right here. Okay, does it make sense? Alright, not very difficult. Alright, 2 new concepts for you to learn. The first one is the concept of a placeholder, where we use a letter for a number that we don't know yet. We might know it later, but we don't know it yet. We know the calculation, but we don't know the input yet. Alright? And we can have an input as x, and we can have an output as the letter y, because we may not know the output as well. And then the second thing is function notation. Function notation. So when we have taken our pictures, our drawing, to actual mathematical symbols, we refer to that as a function, and we denote it as the function of x. And that means some calculations with an x somewhere inside, in some way or form. There may be more than one, it may be to the power of 2, it may be 1 over x, it doesn't matter. There must be an x somewhere contained in the set of calculations. Okay, let's do one more example. Now this time around, I'm not going to draw pictures anymore. We are done with that now. We are not going to draw pictures to show functions anymore. This is now over, because you now know and you understand what a function is and what it looks like. So I'm going to give you a function directly. And I'm going to say, I've got some function of x, and remember now, if you see these symbols, f of x, alright, we say f of x, alright, or you can say a function of x. When you see these symbols, then you automatically know it's going to be some calculation, but there will be x's inside. Alright. Now I'm going to just arbitrarily choose some calculations to use, alright, because we are just going to practice how to work with function notation, alright, and what do we do when the x becomes known. So I'm going to choose this, 2x squared plus 3x minus 10. 2x squared plus 3x minus 10. Okay, so can you see a number of calculations? We've got this plus 3x, we've got this. There's a number of calculations or some calculations, and we've got x's in those calculations. There's one right there, and there's one right there. Okay, so it means we've got a function of x. Alright, now I'm going to ask you to calculate the value of the function, calculate the value of the function of x, where x is equal to, let's make it 2. calculate the value of the function, all right, the function f of x, where x is equal to 2. All right, let's do it. And so that means that wherever we had an x, we need to replace it with a value of 2, because the x is now known to us. So let's go and have a look at what we have. We've got 2 multiplied by 2 squared. All right, we are replacing that x with a 2, plus 3 multiplied by a 2 minus 10. Okay, and let's go and see what this is. We've got 2 multiplied by 4 plus 3 multiplied by 2 minus 10. All right, just one thing before I go on. If I give you 2 times 4, you know that's 8, but I can also write it like this, 2 times 4. The point that I've put between the 2 and the 4, that point is a multiplication. It's not 2, 4. It's not a decimal number. If I wanted to write a decimal number, I will put a comma inside. But it's not a comma, it's a point. So 2.4 means 2 times 4. So don't worry about this too much. We will do so many of them that in the end you will begin to read it like you read your ABCs, all right? It's going to become second nature to you. If I show you 2.4 or a 2 and a point and a 4, you know I mean 2 times 4. Okay, and now it's simple. 2 times 4 is 8, plus 3 times 2 is 6, minus 10. So we've got 8 plus 6 is 14, minus 10, and the answer then is 4. All right, and we say the function or the value of the function where x is equal to 2 is 4. The value of the function where x is equal to 2 is 4. All right, and we can stop there for today. Okay, so again, I've said it a couple of times and I'll say it again. There might be times in mathematics where we know the calculation, we know the function, all right? The function is some calculations that transforms an input into one output. All right, some calculations in a sequence that takes an input, transforms it, and gives us one output. That's a function. But sometimes we don't know what the input must be. That's unknown to us. And so what we do is we use a placeholder. The placeholder that we use letters of the alphabet. And it can be any letter, A to Z, it can be any letter, it doesn't matter. But the most common one we use is an X. We use X for the placeholder. Then when we feed X into our function, all right, it's going to give us a mathematical function. And we can write that in the form of the function of X, which is equal to some calculations. It can be any calculations, there can be any number of them. It can be small, it can be large, it doesn't matter. The important thing is that inside those calculations, there must be an X. There can be more than one X, it can be to the power of whatever, it can be 1 over X. It really doesn't matter. The only important thing is there's an X inside. Okay, so we had something like this, 3x squared plus 2. And then the final thing we had a look at is when the value of X becomes known to us. Let's say for instance it's 2, then we say the function, the value of the function where X equals 2, and what we do is we replace all of the X's in our function with the value of 2. Alright, easy peasy, not too difficult. Okay, if you don't understand, questions in the comments or rewind the video, just have a look at it again, have a look at it over and over and over until you understand these new concepts that I've introduced to you today. In my next video, we'll go and have a look at the rules of algebra. Some more definitions and the rules. And that's because we're now using letters in our equations, all right? Letters in our calculations. It means the rules are going to change somewhat. We've got a new set of rules that we have to learn and we have to use. All right, so that's coming in the next 2 videos. Thank you very much for watching with me today, for learning with me today. I appreciate it a lot. Go and like and subscribe and tell your friends. Please take care of yourself and I'll see you again in my next video. So keep well until then. Bye-bye.